Okay, let me take a few more problem. In my last lecture, I have taken three problem to explain or how to use the at rest condition, then a combination of everything, water table and then surcharge, and then we have taken another when there is a sloping back the wall, how to consider in the analysis. Next, I will take a problem which will have different layer, two layers actually sometime. The soil have top layer will be something, bottom layer will be something else. There may be C soil, there may be c-phi soil, there may be only phi soil. So, all combination if there, then how to calculate or what is the changes in calculation. Let me show one by one. So, let me take problem number 1. The problem number 1 is like this: a retaining wall with smooth vertical back is 8 meter high and retaining a 2 layer soil backfill with the following properties. So, 0 to 4 meter, that means from the top a depth from the top of the wall, C is 0, phi 30 degrees and gamma 18. So, this is a cohesionless soil basically first layer. Second layer 4 to 8 meter depth from the top of the wall, also again C 0 phi is 35 degrees and gamma 19.0 kilonewton per meter cube. So, again this is also cohesionless, but two different cohesionless soils are there. So, and the location of water table is at a depth much below the base of the wall. So, that means in between water table could have come, but here it is given that water table is much below the base of the wall. So, that pressure calculation, water table effect will not come in picture. So, determine the earth pressure diagram against the wall and determine the total active thrust and point of application. So, this is a smooth vertical wall. So, simply straight we will go Rankine's method, and when it is 2 layers. So, only there will be some changes in calculation. So, that will show one by one. So, let us take the wall first. If it is a wall, eight meter wall and up to 4 meter the soil is something. This is your phi equal to 30 degrees and C equal to 0 and gamma equal to 18, and here phi equal to 35 degrees, C equal to 0 and gamma equal to 19. So, and backfill also this level backfill. So, for this you have to find out, I can say K A 1 will be equal to 1 minus sin 30 by 1 plus sin 30. So, it will be 1 by 3 and K A 2, that means layer 2 active earth pressure coefficient 1 minus sin 35 degrees divided by 1 plus sin 35 degrees. So, this gives you a value 0.27. This is 0.333. Now, to draw the pressure diagram, I will do like this, and so from here pressure diagram will be something like this. So, how it will be, how much it is? This will be 18 multiplied by 4 multiplied by 0.333. So, it will be equal to ultimately 24. Okay. And after this, so because of this soil this much pressure is acting here, and you can also at this level you can assume that this is a surcharge. So, this will be constant up to this will be constant for this soil. Because of this soil layer, what will be the pressure at this level? This much. Now, because of this soil layer, So, you have to find out additional earth pressure. So, assume this is the 0 level. So, from here you will get the pressure diagram. So, this will be suppose something like this, and what will be this value? This is already 24, and what is this value? This will be equal to 19 multiplied by 4 multiplied by 2.27. So, that is equal to your 20.52. This is 20.52. So, we have now, that means we have to find out the thrust on the wall because of this backfill active thrust. So, this can be divided into 3 parts now, 1, 2 and this is 3. And so, you can find out P1 will be equal to half multiplied by 4 multiplied by 24, it will be equal to 48, and your P2 will be equal to 24 multiplied by 4, that is 96, and P3 will be equal to this one. So, half multiplied by 20.52 multiplied by how much? This height is 4. So, that is actually 41.04. Then your P A will be equal to 48 plus 96 plus 41.04. So, that gives you total 185.04 kilonewton. And now, we have to find out your point of, suppose this thrust is acting somewhere here P A. So, you have to find out what is the distance y bar. Now, this individually this is 3, this is suppose y 3, and this one suppose is acting at the midpoint. So, this will be suppose y 2, and this was suppose acting somewhere triangle. So, this is suppose y 1. So, y 1 will be equal to this 4 plus, from this reference 4 plus 1/3 of 4. Okay. So, this is actually 4 plus 1/3, and y 2 will be equal to this is. So, from here y 2 will be 4 by 2. So, 2, and y 3 will be equal to this one. So, 1/3 of 4 meter. So, this is the distance. Now, we can find out 185.04 multiplied by y bar will be equal to P 1 is 48 multiplied by 4 plus 4 by 3 plus 96 multiplied by 2 plus 41.04 multiplied by 4 by 3. So, if I solve for y bar, we will get y bar equal to 2.71 meter. So, when there is a 2 layer, if it is a single layer, it could have been 1/3 from the base, 1/3 of 8. How much it is? It is 2.666. So, if it would have been a single layer, whatever may be the phi, then I could have gone a single diagram, and your point of application of the thrust would have been at 2.666 meter from the base, and because of this we have done so much of calculation, and we can find out that the point of application is at a height 2.71, slightly above 0.5 meter, almost above, slightly actually 0.1 meter above. So, so this much is the so this is actually what, if there is 2 layer soil, what is the change? So, this is the change. Up to this the diagram will be 1, and this diagram at this level whatever pressure we get, that will be the surcharge to the next layer, and then additionally you have to find out for the second layer the separately. So, then we can find out the entire area to get the thrust, but instead of doing entire area together, what we can do, we can divide into known parts, known different parts of known areas. Suppose a triangle, rectangle, etc. area easy to find out. So, we divide into square and rectangle, or square and triangle, rectangle, and based on that we have determined the area for different components, and we have also determined the point of application of individual forces, and then assume that resultant forces acting at a distance y bar, and then we take moment with those all other force, and now resultant force you have to take moment, and they will be balanced. So, there will be moment balance. So, that from there actually we can find out y bar. So, 2.71, and if would have been a homogeneous layer, it could have been 2.66 meters. So, this is the difference finally we are getting. So, let me go to the second application. Second application somehow is a 2-layer soil again. Top layer is, you can say, is a phi soil, and bottom layer is a c-phi soil. A retaining wall 6 meter high supports 2 layers of soil, each having thickness of 3 meter. The properties of the layer are upper layer C0 phi 30 degree, gamma bulk 18, and lower layer C 10 phi 18 and gamma bulk 19. Determine the total lateral thrust and its line of action above the base of the wall. So, this is a 2-layer soil. Upper soil is cohesionless and bottom soil is with cohesion. So, you have to do again another layer soil. So, let me see what are the changes will be here. So, here 6 meter high wall, 6 meter high wall, and it is layering is at midpoint 3 meter, and here actually C0 phi equal to 30 degrees and gamma equal to 18. Here C equal to 10 only, phi equal to 18 degrees and gamma equal to 19. So, this one we can find out the pressure diagram here. So, again once again we can find out Ka1 1 minus sin 30 divided by 1 plus sin 30 equal to 0.333, and Ka2 will be equal to 1 minus sin 18 by 1 plus sin 18. So, that gives you 0.53. So, since up to this it is a cohesion layer, a cohesionless soil, the pressure diagram or lateral earth pressure diagram will be something like this. Okay. So, this value will be equal to 0.333 multiplied by 3 multiplied by 18. So, that will be equal to finally 18, and now this will be acting as a surcharge, but now when I will be doing this layer. So, this layer I can forget about the presence of this. Now, for if I assume this from here, and then c-phi soil, you know P A will be equal to gamma H K A minus 2 C root K A. Okay. So, here what I can do now at this level, what is the sigma? Sigma I will take 18 multiplied by 3 already there, and K C since I am doing the second layer. So, K A for this layer to be used. So, 0.53 minus 2 C 2 multiplied by 10 multiplied by root 0.52 or 0.53. So, if I do this, this value will be your it will be 14.06. So, 14. So, this was 18. So, 14.06, that means it will go this direction. So, it will be somewhere here. So, 14.06 here. So, that means your and from here actually it will be going by straight line, something like this. So, so that means if I want to find out value at this point, how you can find out P A at the base will be equal to we can find out so that can be found out 18 into 3 plus 19 into 3. This much sigma is acting multiplied by Ka 0.53 minus 2 multiplied by 10 multiplied 0.53. So, this if you calculate you get 44.27. So, that means so this is 14. So, this entire value, the entire value this is actually up to this is 14.06 and this value then it will be 30.21. So, this point to this point 30.21, this point is 14.06. So, now this is the pressure diagram you have got. You have to find out the thrust. So, to find out the thrust I can find out different component 1, 2 and this is 3. So, that means P 1 will be equal to half multiplied by 18 multiplied by 3. So, it will be 27 and P 2 will be equal to it is 14.06 multiplied by 3. So, that is actually 42.18 and P 3 will be equal to half multiplied by 30.21 multiplied by 3. So, that will be equal to 45.315. So, P A will be equal to altogether P 1 plus P 2 plus P 3. So, that gives you 114.495 kilonewton. Now, individual suppose this is y 1, then this is suppose y 2 and this is suppose y 3. So, force 1 acting here, force 2 acting here, force 1 acting here. So, 3 acting here, 2 acting. So, that means y 1 I can find out y 1 or 3 plus 1 by 3 into 3. So, this is the one y 2 will be equal to 3 by 2 and y 3 will be equal to 1 by 3 multiplied by 3. So, that is 1. So, now if I assume the thrust resultant thrust acting somewhere here and that is at a distance y bar, then y bar multiplied by P A will be equal to P 1 y 1 plus P 2 y 2 plus P 3 y 3 and if I do that all values if I put, then we get y bar equal to 1.891. You get y bar equal to 1.891. So, that means because of this two layer soil the thrust on the wall is equal to 100 495 kilonewton per meter length, and it will act at a height 1.89 meter from the base of the wall. So, this is another application, and then let me go to the third application. So, this problem actually, though I have not given much importance to Coulomb's theory, and this may be for this undergraduate course may be avoided, but since I have introduced to find out the difference between Coulomb's and active Rankines. So, I have taken one problem, but I may not able to solve fully, just see, I will just show what is the differences. Here actually you can see determine using Coulomb's theory the total active thrust on a vertical retaining wall 5 meter high if the soil retained has a horizontal surface level with the top of the wall and has the following properties: phi 36 degrees, gamma 19 degrees, and assume delta equal to 0.5 phi. So, while discussing this Coulomb's theory, and we have I have used this formula. This is a very classical problem and a very old solution. Different people gave different ways the solution, and in some books we get in this form, and some book also we get in some separate form, which may be little better. Also, while comparing with different books, I found some mismatch between in some places, and I could not decide which exactly is the correct one. I have to see the original publication to see the difference. So, for the time being, though this is another type of expression, somewhere here there will be a small change may be there. So, I am not using this. Instead of that, I will be using another form of equation. The equation was given in this form, like if the wall is something like this, and if this is I and this angle is beta and friction angle is delta, I beta delta, then your expression for K A is given by sin square beta plus phi divided by sin square beta sin beta minus delta 1 plus under root sin phi plus delta, then sin phi minus I divided by sin beta minus delta and sin beta plus I, and this is whole square. So, this is one expression is given. So, all angle beta is this angle here, I is this angle here, and delta is the friction between the in the wall, friction angle. So, this is another form of equation can be used. So, I will try to use this, but with respect to this problem you can see the vertical retaining wall with retained has a horizontal surface level width, that means it is like this. So, I become 0, and beta, since this is the angle beta and it is a vertical actually is mentioned, total thrust on a vertical wall. So, beta become 90 degrees and delta will be 0.55. So, delta equal to 0.55 and it will be 18. So, if this is the values, then based on that we can put the formula, formula there we can get sin square, okay. It is K A will be equal to sin square sine square 108 it will be divided by sine square 90 sine 72 1 plus sine 54 multiplied by sine 36 divided by, this is under root of course, divided by sine 72 and sine 90, and this is square. So, if you all are in terms of sine values, the angle, so if you calculate, this comes 0.4231, and then your thrust will be P A will be equal to half gamma h square K A, that is another formula. So, half multiplied by gamma is given somewhere, we can see gamma was 19. So, gamma was 19 and h was, I think, how much, 5 meter. So, you can say 5 square multiplied by K is 0.4231. So, this gives you a value 100.48 kilonewton. And of course, this problem if I do this is the vertical, we have considered vertical wall, and this was a 36 degrees. So, your if I this wall is something like this, 5 meter, and this is the one, and only delta is there. So, if you ignore delta here, and you could have got K A, we could have got 1 minus sine 36 degree divided by 1 plus sine 36 degree, then that value could have come 0.259, and then your P A could have come half multiplied by 19 multiplied by 5 square multiplied by 0.259. So, whatever the value it could have come much smaller compared to this one. So, this is the difference between Coulomb and Rankine's. Of course, if you know the Coulomb's theory, and if you want to use Rankine's theory, the appropriate values actually you have to see when Coulomb's is a generalized and Rankine's is a special form. So, like wall inclination, you can put beta equal to 90 degrees. So, it become Rankine's. Similarly, I, if you put 0, then become Rankine's level surface. So, like that, the in combination both can be done, but in general we use Rankine's theory because the expressions are simple. If necessary, you can increase the value little bit for the design to make it safer, otherwise it is enough. So, this is one problem I have taken with the purpose, since I have discussed Coulomb's theory, what way it is different, and all those things I want to highlight. So, I hope that is enough. So, with this I will stop this one, and let me close here. Thank you.